So in 4.6, we're going to talk about this thing called CPCTC. Okay? And Mr. Ausel is a veteran teacher, so he can say it very quickly on a Monday morning. But CPCTC stands for corresponding parts of congruent triangles are congruent. Okay? So when I look at that statement above, right, corresponding parts of congruent triangles are congruent. Okay? When you write CPCTC on your proof, okay, what you're saying is, because the previous statement stated that the two triangles are congruent, and we went through the processes 1 through 6 we've done before in terms of proving two triangles are congruent. But once I say that those two triangles are congruent, the two triangles are congruent to each other, then I can say all of its corresponding parts, meaning angle M matches with angle T, and since angle M is congruent to angle T and they're corresponding, they have to be congruent to each other by CPCTC. And once I state that, I might use the fact that those two angles are congruent and my alternate interior angle theorem to prove that those two sides are parallel. Alright? So when we're doing these proofs, guys, we're going to go through the first 6 steps like we've always done in terms of solving proofs, but then we're going to add on a couple of extra to prove something else. Alright? So let's go ahead and look at the next proof. We'll do the next one together, and then we'll kind of slowly pace you guys out so you guys can try some on your own. So here we have a very odd-looking picture here. I see how many triangles? 1, 2, 3 maybe? Maybe more than that. But we're not worried about that right now. All we can start with is using our given information. Okay? Whenever you're doing a proof, you always want to start with what's given to you. So they give me that AB and FD, they bisect each other. So the first thing I'm going to do in step 1 is I'm going to write down that AB, segment AB, and FD, segment FD, bisect each other. What would my reason be for that? It'd be given, right? Good. So that's my first step. You always want to write down your given information first. Now, I need a hand here. But if I look at this first statement, I need a hand in the air. What kind of information do they give you in this first statement that helps you lead you to your next statement? Yeah.
Since AB and FD bisect each other, that would mean A
I can look at AB, and I can say that AE is congruent to EB. Why can I say that? Because they bisect each other. And what does it mean to bisect each other? Cuts it in half, right? So, I know that AE is congruent to EB because it's bisected by this segment, FD. Alright? So, remember statement number 2 then might be that which two segments are congruent to each other? AE is congruent to EB. And what would my reason be if those two segments bisect each other? Well, not really definition of midpoint, but you're on the right track, Haley. Okay? So help me out here. If these two segments bisect each other, if I'm going to look at my proof packet, right? I'm proving two segments are congruent. So everybody right now, go ahead and pull out your toolbox. And if I'm trying to find two hidden segments, I'm going to come back to you, Maybelline, okay? If I'm looking at those two segments, and they're congruent to each other, and they're bisecting each other, where would I see the word bisect pop up there? Definition of segment bisector. Good. So my reason for step 2 would be definition of segment bisector. Always using the previous statement to help you with your next statement. Right? That's all we can ever use. We can only use what's given to me or what I can prove with a reason. Alright, step 3. We can't move forward yet because we've got to keep using what we have. So Anna, what would you also say, or what else can you prove congruent?
Angle is congruent to angle FEB because they're vertical?
Time out. Let's keep using what we know, okay? We know these two segments bisect each other. So, sorry, yeah. What other segments would be congruent? Yeah, Ann?
DE and EF.
Yeah, I can look at this picture. I can see that DE is congruent to EF because AB also bisects the other segment. So I can say that DE is congruent to EF. My reason would be the same as step 2. Definition of segment bisector. Alright. So that's good. We used all of our given information. We found the two segments were congruent based off of my segment bisector definition. So now I need to find something else that isn't given in my original written information, but it might be given in my image when I look at it. And then when I'm looking at that image, what's something that I could probably pull out that was hidden when I look at that picture? AED, if I look at angle AED, what's its relationship to the angle that's across from it? Vertical, right? They're vertical of each other. So I could say that those two vertical angles are congruent based on the picture. Okay? So it's not always what's given to you in the word form, but it also could be stuff that's given to you hidden in the picture. Yeah?
Can you also just say angle E is equal to
Now, actually, if I look at vertex E, I have 4 different angles that are sitting right here. I have this guy, I got this guy, I got this guy, I got this guy. I got lots of angles around E. So I need to be very specific about the names of those two angles. Marissa, can you give me the 2 names of those angles? Angle AED. Can he be congruent to angle FEB? Very good. So I'd be very specific. I use 3 letters to name that angle because I'm looking for 2 specific angles in my picture, and I actually draw those on my picture. My reason would be what? Vertical angles, right, vertical angles. I'm looking at some of your quizzes that you guys just got back, and a lot of people are just stopping right there writing vertical, okay? I gotta be careful with that. I want to make sure I'm very specific so my person understands what I'm talking about. So I'm going to make sure I write vertical angles. Okay? Alright. Now, I really need to be able to kind of use what I'm given. I have 3 corresponding parts that are congruent. As I look at those 3 corresponding parts, what 2 triangles include those 3 corresponding parts? Which triangle includes the AE, this angle right here, and DE? What triangle am I looking at there? A, E, D, right? That's my one triangle. What's my other triangle for the 3 other parts that are corresponding congruent? Jason? EBF, right? Since I have 2 congruent angles that's included between 2 corresponding congruent sides, what posture would I use to prove those 2 triangles are congruent? Think about it. Yep, side, angle, side, because I have 2 angles that are included between 2 sides. So this would be side, angle, side. I know, in step 5, that the 2 triangles which you guys are named, AED, be careful here, which triangle is congruent to AED? Look at the letters, look at the order. Rigo, if I had to find another triangle congruent to AED, what triangle would it be? I gotta be careful with the order. I'm going from A to E to D. So watch up here. A, E, D. So if I'm going from A to E, which corresponding side goes from A to E on the other triangle? B to E, and then E to D means I'm going to go to E to F, right? So I'm going to name this triangle BEF. BEF. And one more time here. What, Jasmine, what would I use here for this triangle's congruent? Side angle side, good. So, side angle side is my postulate. The only thing left I have to show here is that if I know these two triangles are congruent, I can show that all the corresponding parts on those two yellow triangles have to be congruent to each other. Corresponding, meaning that they match in terms of the congruency statement. So, when I look at what they're trying to prove congruent, where is this angle right here? Where is angle ADF? Where is that located on my picture? ADF. Isn't that this guy right here? Right? ADF. And then angle F would be located up here. There's only one angle formed by vertex F. So, are those two spots matching on my corresponding two triangles? Yeah. Angle D matches with angle F. These two are corresponding parts, so since the triangles are congruent, they have to be congruent themselves. So I can then use my proof line. ADF is congruent to angle F. And my reason would be the new one we just learned. C, corresponding parts of congruent triangles are congruent. CPCTC. And we're done. Because all they asked me to do was to prove that these two angles are congruent. And once I do that, I'm finished. Okay. So what we're going to do next here is I'm going to kind of float around, see how you guys are doing. But I want you to get this next proof started on your own. Start with your given information. Use that given information to find hidden pieces. And then go back to the picture and see if there's anything else hidden that you could find. Alright guys, so the good news is you're getting down the given information. So the first statement is going to be that WY bisects an angle ZWX. However, when I read that statement, what's being bisected? Yeah, what's being bisected? ZWX, the angle is being bisected, right? So if the angle is being bisected, I have to look for this angle, ZWX. That's up here, right? And it's being bisected. So what do I know about its two parts? They're congruent to each other. So this angle would be congruent to this angle. Because the angle is being cut in half. The angle is, this segment bisects that angle. So the reason was given for this one. We're going to come back to and state that those two angles are congruent. So most of you are going ahead and writing your second given statement, which is fine. You can do that. Angle Z is congruent to angle X. That was also given. But once I write given, I want to make sure I label that those two angles are congruent. So, this angle is going to be congruent to this angle. Z and X. Angle Z is congruent to angle X. Now, I know that these two angles up here at W are congruent to each other, but I haven't stated it yet in my actual proof. So I need to go back, and I need to specifically say which two angles are congruent to each other. So Nathan, what's the angle right here? What's this guy's name?
ZWY.
Angle ZWY. And he's congruent to angle XWY. The reason that they would be congruent is all based off of the original given information that told me that this segment bisected an angle. So I was able to find two hidden angles that were congruent. So Susanna, what would my reason be here for number 3? Definition of angle bisector. Good. All right, so I used everything that was given to me.
Where's this? Like what you put?
Sorry? I have 2 corresponding angles that are congruent. The only thing I need is something else, either a side or angle, that's not in my given information here, but in my given image. Yep, Johnny?
ZY is congruent to XY.
ZY is congruent to XY.
Yeah, because of definition of segment bisector.
See, that's the one issue we have here, okay? When they gave me this piece of information, okay, what is being bisected? An angle. Nothing tells me from this given information or from my picture, well, maybe from my picture, but I can't assume it, okay? I can't assume that WY bisects the segment ZX. Everybody understanding that? I can only look at what is given to me here, okay, and what is exactly the same. I don't know for a fact that they're congruent to each other yet. Maybe later on I'll be able to prove it, but not right now. Yeah?
ZW is congruent to WX because of if base angles are congruent, then the side opposites are congruent.
Okay. We can do that, right? How many people went in a different direction? Yeah.
I said that YW is WY reflexive.
Okay. And both of those students, both of them would be correct. So when I grade your proof packets, guys, there's different ways that you can approach a problem depending on what's given to you. Okay? You could have went with Anna and you could have said, hey, look, the base angles here are congruent. So when I look at WZX as an isosceles triangle, the opposite sides of those congruent angles would also be congruent. And you would use the base angle theorem. Or you could have been like some students that I walked around, and I saw that they shared this segment, both triangles, 2 of the smaller triangles, shared this segment WY, so WY would be congruent to WY because of the reflexive property. So on step 4, I have 2 options. I can use the base angle theorem, or I can use the reflexive property. It really doesn't matter which one you choose. Okay? For me, I like using the reflexive property because it's just an easier property to find. Okay? But when I pick that side, the 2 triangles that I'm visualizing here are triangle ZWY and triangle WYX. Well, no, it actually doesn't want to be written the way I said it. I have to make sure I match the corresponding parts. But when I look at those 2 triangles, triangle 1 and triangle 2 here, look at what I can choose. I can choose, if I went Anna's route, I could choose angle, side, angle as my reason for those 2 triangles to be congruent. Or, if I went where Ethan went, I could have done angle, angle, side. And both of those postulates work. Both of those answers are correct. So, before we move forward and state our reason, we also have to state our triangles congruent. Tristan, can you give me one of the triangles that I labeled there? Which one do you want to pick? Pick the order of the letters for me. ZWY. ZWY. And once I choose that order of letters, I have to follow that through my entire picture. Adam, if I'm going from Z to W to Y, I'm going to go X, W, Y. Very good. And my reason, based off of what I found in my proof, using the reflexive property, I would use angle, angle, side. If I went the other route and I did the base angle theorem, then I'd be using angle, side, angle. But both would be correct.
Wait, Mr.
Yeah.
What if you just, could you write both of them if you wanted?
No, just one or the other. It'd be redundant.
If you did the reflexive property and the base angles.
X, Y. If you did both, it'd be redundant. You would have an extra statement in there you don't need. And Mr. Also, if you wrote step 5 as that, as the base angle theorem, using the base angle theorem, and then you wrote that, I would probably just put a big slash through one of the lines and being like, unnecessary. Okay? Because you only give your reader as much as you need. Don't go over the top with it. Okay? So now that I know the two triangles are congruent, I need to look at what I'm trying to prove, which for us is that zy is congruent to xy, and I'm going to label that on my picture to see if they correspond with each other. So zy, that's right here. Does he correspond to xy? Does zy correspond with xy? Look at your congruency statement. Are they in matching spots? Yes. So those two segments are congruent. Zy is congruent to xy, and my reason being corresponding parts of congruent triangles are congruent. And I can shorthand that by writing CPCTC. Now the next proof is a prime example of if you can use your theorems correctly, you can step a lot of segments and do this, I think, proof in maybe 2 statements, 2 or 3. Okay? See if you can get number 4 started here. Okay? See if you can get started. Label your given information. Draw on your picture and look for what you're trying to prove. They give you they give you almost too much information sometimes. So let's go ahead and label our given information first. Some of you are shorthanding perpendicular, that's fine. DE is perpendicular to FC. They're perpendicular to each other, right? They're perpendicular to each other. Bella, when they're telling me perpendicular lines, what is that giving me? If I'm given that, what is that telling me moving forward? Well, they're giving me 2 lines are perpendicular. They're not talking about bisecting or midpoint or anything like that. Anyone want to help her out here? If those 2 segments are perpendicular to each other, where does perpendicular pop up on your toolbox? Proving angles are right angles, right? So if these 2 lines are perpendicular, what does it tell me about these 2 angles? They're both right angles. So I have to be very specific about what those right angles are. Right? What's the name of this right angle right here? What's the name of this guy? Paul? FED. So I can say in step 2, angle FED and angle CED are right angles. Definition of perpendicular lines. Okay. So, knowing that those are right angles, what else could I do?
EFD, ECD.
Yep, those two angles are congruent to each other, right?
No, the other way around. We start with E and go to F.
EFD.
Yeah.
How do you know those are congruent? We're trying to prove that at the end, actually. So if you were able to state that, we'd be good. We'd be golden. Yeah? Right, that'd be reflexive, right? That'd be hidden. So if we knew that, that'd be great. So we first stayed at the right angle, so we're good right there. Okay? Let's go ahead and before we jump to more hidden stuff, let's label something else that was given to me. What else was given to me before I jumped to the reflexive property? Look at this. I can say that DF is congruent to DC. And that was given. Some of you have that in step 2 rather than step 3, but that's fine. Now, Jara, you said that that DE is congruent to itself, right? So I can say that DE is congruent to DE by the reflexive property. Okay. When I look at that information, what proof am I using here to prove those two triangles are congruent? Based on my picture, what would I be able to prove? Yeah. That by hypotenuse leg, these two triangles would have to be congruent to each other. And I'm going to pick the name of the two triangles. So you said FDE. FDE. So if I look at the letters FDE, F to D to E, I have to go from C to D to E. That wasn't the goal. The goal was to show that angle F was congruent to angle C. Are angle F and angle C congruent? The reason being, F and C are corresponding parts of the two congruent triangles. So since they're corresponding, they have to be congruent to each other. So I can say in step 6 here, angle F is congruent to angle C because of corresponding parts of congruent triangles are congruent. Now, that took us 6 steps. Did anybody figure out a way to do it in 2 steps? Yeah. Thank you.
If two sides are congruent, opposite equals are congruent.
Nathan went right to this statement right here, statement 3. You could make statement 3 really statement 1, right? And you could say that DF is congruent to DC, right? And based on the picture, what kind of triangle is DFC? If those two sides are congruent to each other. There's a name for it. It's isosceles triangle, right? And if those two sides are congruent, what would make these angles congruent? The base angle converse theorem. So you have the converse in there too? Because remember, if I'm trying to use the segment to prove angles congruent, I'm going to use that converse property. So you could have jumped all the way down here to step 6 and said that the FC is congruent, angle F is congruent to angle C. The reason would be, okay, the reason would be converse base angle theorem. So that's a 6-step proof that could have been done in 2 steps. So on your proof packet, I give you a lot of number of steps to use. If you do it the way, using all the given information and trying to follow the steps, it'll most likely take that number of steps. But there's some ways you can do it in fewer steps. It's all based on what you can see and find. Alright? Are there any questions about that? Alright.